Good morning. This is H coming at you again with another Inventor tutorial. This tutorial is going to be all about using the equations in Autodesk Inventor 2023. Equations, parameters, there's a whole thing you can do with this. So what I'm going to do is first kind of go over what I have on screen. This is going to be one of probably a longer video, a little bit of complications. Obviously, trying to record this live, there might be some mistakes in it, and you'll see me, if I make those mistakes, correcting them, talking through those things as we look at what it is the equations, the parameters do in Autodesk Inventor. So the first thing we're going to open with, though, is the idea of design intent. Design intent is if you wanted to make a part, file, an object for a specific job and keeping that job or that intent in mind. And then, of course, if that part file could be scaled to a larger size or a smaller size, what would it look like in a scaling type of scenario, right? And that's where the parameters comes in. The parameters is really the way that we're able to scale things up and down within Inventor, as long as we can get the relationships between the different dimensions accurately assessed and those relationships and those equations put in, so that when you change a number, like a specific number, one number, it then affects everything else. Okay, so this is what we're going to look at today. Here's our part file, or our sketch here. So we have a 2-inch by 4-inch and 2-inch and then 1. And I dimensioned everything. I wanted a fully constrained sketch to start out with because I wanted you to already see kind of the proportional relationships between some of these dimensions, because that's going to be key in what we make our equations be when we're going through this, right? So 2 is our height of this piece here, of this line. This height times 2 gives us our length, right? This height divided by 2 gives the length of these bottom lines. This line here, the length is equal to it, right? So there's some very purposeful, intentional dimensioning here to kind of communicate and teach what is going to be going on with the equations parameters tool. Okay, so be aware of that. Like this is again kind of like a best case, easiest scenario in order to come up with what we're doing. All right. So as we look at this here, again, we have our sketch, but where we're going to be using most of our time here is in this box here. So again, equations are, or the parameters are kind of maintained and viewed and edited in this parameters chart. So if I open up this chart, here's what it looks like here. Okay, so there's a couple of things we need to really set up. Number one is in this chart, this first column is the parameter name. Now, a parameter name is just the name of a dimension and where that dimension is. So dimension 0, like D0 here, and it is consumed by sketch 1. We can see that here in the second column, like where it is. Everything's going to be in sketch 1 because we only have that as our only feature that we've made. It's in inches, and then the equation is D0 equals 2-inch, right? You see that? So then we have the nominal value, which is the number value of that, the kind of the absolute value, and then the model value. So we have some different stuff that's here. Default tolerances is all good. We won't be messing with tolerances at all in this video. Okay, so D0 equals 2. Now, what this D0 is, and all these dimension names here are the dimension names given. I'm going to hit done here just to go back to my sketch. Are the dimensions given, the name, sorry, given to the dimensions as we make them, right? So the first line that I made was this one here, going up vertically 2 inches, and I dimensioned that. Right. And so Inventor automatically named that D0 by just the default name. and then every dimension after that, in order that it was created in the sketch, was given another name. But D0 we know as height, right? Again, I'm not going to name something, creatively. It's the name of what it is for the part file, right? So this is the height of the object here, this 2 inches here, this vertical line right here. And that's going to be always 2. And it's going to always be 2 until we change it. And then once we change it, I want everything else to change according to this dimension, right? So this is where this interrelated proportional kind of equation scenario starts happening. So D1, this is the length, right? Or the width. We could do either one. The name, it's just kind of describing what it is, right? The length of the entire part is going to be the height multiplied by 2. So right there. So here we have our very first dimensional relationship happening. So I'm going to hit done for now to kind of go in and show you what's happening here. So this we just named as height, right? We name this dimension as height. Dimension properties. We'll go, look, there it is, name height, right? And we change that in the parameters chart, right? Now this one here is what we changed to an equation, and you can now see f of x, just like it was, like it's a function in mathematics. F of x is here to to tell us and to differentiate this, because this is now this first length dimension is here, and it's an equation, so it's telling us that it's an equation. If I right click on this and go to dimension properties, you can see again it's the length. It's going to give us other dimensions in there, but it's the length, right? And its equation, the function that it is using to come up with this number 4, is given to us in the parameters when we did it. And again, it was this height times 2, right? And again, this is what I meant by, in the beginning, we were looking at proportional. We're doing proportional relations here, right? Now this dimension here, 2, is the next one here. This is dimension 4. So this is height 2. Height 2 is just going to be equal to height, right? So again, we have the height here. The name of this is height, right? Then we have the length, which is height times 2. And then we have height 2, which is just equal to height as well. So whatever we change this number to be, instead of a 2, we change to something else, it's going to automatically make this the same, right? Now D3 is, again, because I went this direction, like coming down here, this bottom line here, this is going to be the height divided by 2, because it's 2 divided by something equals 1, right? So what I've already dimensioned this into be, I just wanted to make sure that it was easy. So this dimension 3 is going to be left bot. We're just say left. Oh, sorry. No, this is the right. There's your live mistake. Correcting it now. Right bot. So like the bottom right length. So we'll just say L. Right bottom L length. Right. And this is going to be the height divided by 2. So we're getting all these equations in here so that when we change one number, is changing all the other ones. This one here, D4, is going to be this bottom height here, right? So this D4 is bottom H, and it's also going to be the height divided by 2. There it is. Now, take a moment here. This UL that keeps appearing in my equations box, that's just the symbol for units. And it's like a placeholder. Instead of putting inches there or millimeters in there, it just says UL. So it ends up being whatever unit system it is in the sketch, it automatically translates it to the right dimension. Now this D5 is the bot like cut height, or no, cut length. We'll do cut length. And what I mean by that is this line that comes across here, this two, so this little cutout that's here, it's not a perfect rectangle. There's a little cutout that's here. And so that cut is there. And this is just going to equal height. We're not going to change this. Now, what's interesting is that if I do this, if I do the H lowercase, there's an equation error here. You might have already, if you've been doing this or following along and trying to recreate this, you might have already had this. My apologies. But the reason is whatever you put in the equations here, it must match your parameters. Your parameter names are your variables. So like think in math, it's your variable X, variable Y, variable Z, A, B, C, whatever it happens to be, the variable name, those are the parameter names. And so if they don't match, even case sensitivity, it's going to cause you problems. It's going to give you an error. So make sure whatever you're using here is correct. Okay. Whatever you've used in this, you've used over here. Okay. So now we have, again, we're kind of making our way around. We have a 1-inch dimension here for dimension 6 right there. And dimension 6, the name of this is going to be, this is going to be bot height 2, right? So this is going to just equal bot height, right? Which means it's going to be height divided by 2, right? But we're gonna do a different equation here just because it's been height all the way through. We could type in here height divided by 2 like we did for bottom height over here, like in the beginning. So bottom height was this line here. Bottom height 2 is this line here. They are equal to each other. Okay, so we could do an equation that is just height divided by 2 and do the same equation in this box, or we could just make it equal to this one. Either way works because it's going to be the same nominal value when it's calculated out. All right, so this sketch 1, this is D7. D7, I'm going to hit done real quick. I'm going to check to see if it was this dimension here. Yes, it was. Okay, so D7 is the diameter of this circle here, this circle that's going to be a cutout. So D7 is circle D, circle diameter. And the circle diameter is going to be the height. We'll say, do you want to do a multiplication here or a division problem? That's going to be more of a question, I think, right? So we need to mathematically work out 2 times 0.25, 0.25 is going to equal the 0.5. Yep, there it is, right? So we'll do an equation, a multiplication problem here. It could have also been it could have been division. It doesn't matter, right? It's going to give you the same numerical answer. So the circle diameter here is going to be whatever this number is multiplied by 0.25, right? Now, we're going to do the same thing for these two, right? So D8 and D9, these are, let's see, placement for circle 1. We're just going to abbreviate placement for circle 2, right? Both of these are going to equal, I want these to equal the diameter of the circle. So circle D, and this one here is also circle D, circle diameter, right? So these 2 dimensions here, we'll just double check it. Yep, these 2 dimensions here equal the diameter circle. That way the circle is always going to be kind of like right here-ish in the corner. And that's the design intent. The design intent is so as this thing scales up and down, this circle, whatever size the circle is, whatever dimensions this part file becomes with these equations, this circle stays in the correct position with the finished part. We're going to see that, I hope, right? So that's that. Now D10, let's hit done for a second. D10 might be this dimension here, which is the diameter of this slot tool, which it is. So that's D10. So this is slot diameter. I'm going to change it right here and hit apply because I can do that, right? And that's one way to do it, and it's automatically going to be changed here in the chart. So I'm going to do that for these last little bits here. So the slot diameter is this one here. This is the slot length. So dimension properties, we'll do the slot L, apply that. It's easier to do it this way sometimes because we can see what it is. This dimension here, this is the placement for slot, and then this is the height. It's an abbreviation, but it's an interesting one. And then this one here, this is the placement for slot. We'll do length. Abbreviate that. Now let's go into our parameter chart. And you can see that was a bit faster, right? That's a bit faster to do the renaming that way. But again, it's all done. The work for the equations is done in this chart. So we have to open up the chart anyway. So really, it's a preference thing. Again, it's easier to rename things looking at it that way and doing the dimension properties. Again, you just go to dimension, you right click on it, you go to dimension properties, and boom, you can rename them just like that. Okay. But anything to do with the equations, we need to go to manage and parameters, and then we should be good. Okay. So now slot diameter here, the slot diameter is going to be, again, this height. And this time, let's do a division. Let's just divide it by 4, right? Because that way, it's a bit different of an equation, but it's going to give us the same numerical answer. But it just makes it a bit different, makes it, kind of unique. And then this one here, this is the placement for slot, the height of it, or the vertical of it. This is just going to equal slot diameter. Right? Yeah, that's the best way to do that for sure. So that's the slot diameter. Then we need the placement value of the slot and the length, and that's 1 inch. So here, let's do this. It's going to be height divided by 2. It's going to give us the same nominal value. And then the slot length, that's just going to equal the PFSL. That's just going to equal the one we just calculated, right? So that way they're equal to each other and they should be good. So let's hit done. And now if we look at our sketch here, every single dimension is going to be an equation. It's an FA, except this one, right? Except this one. But when we change this one, everything's going to change and get adjusted. So moment of truth here. Let's see what happens. Let's go down. We're thinking we're going to scale this down. Instead of a 2-inch height of this, it's just going to be 1. And there it is. It scaled, everything scaled down. Everything went down. And then if we do this, so let's see, this is now 2. Then let's say we do this, let's go way up. Let's go like 10. Zoom out a bit. There it is. Everything is still in the proportional, design intended positions of everything. The circle is in the right place. It's just much larger, right? Everything is in the right place. The proportions are all the same. But if we just adjust the height to what we want it to be, there's 2, right? We adjust the height. There's 3. We adjust the height. We're doing all whole numbers. Why? Let's 4.853, just do a random number. Boom. There it is, right? Everything calculated out and working together in sequence and in proportion gives us exactly what we need. Let's go back to 2. So now once all that is done, we can finish the sketch, right? And we didn't have to have the sketch open to do the equations, just FYI, just so you know that. And if we extrude this 1 inch, let's just say 1 inch, we can even go into manage parameters and say, oh, this is the width, right, of the part, and it's 1. But what if we made it just so it's the height divided by 2, right? And that way it will even change the extrusion when we go to f of x parameters. Let me just move this to the side over here so I can change this. So all I'm going to do, I'm going to change this number in this chart to 4. Let me do that right now. 4, enter, and there it is, right? Everything went larger. It scaled up. And if we measure the side of this here, it's 2 inches. So again, everything can be scaled and everything can be adjusted if you get these equations all mapped out with everything that needs to be. Now, if you leave something out, if you don't do every single thing is equal to something, then it's not gonna move something or get something correctly in place, and you can have things that are looking just very strange and very, very weird, right? And it will not work the best way if it looks bizarre, right? Or if the equations are wrong. So if it's 2.5 is my height, there it is again. It just adjusts for us, following and calculating all these things out as these nominal values go. Now, this last one here, this D15, this is the draft of the extrusion, what degree of draft or tapering the extrusion has, which is in the extrusion tool video. We talked about that. So the default is always 0. And so if we wanted to adjust that, we could do that last dimension or that last parameter in there and have a fully defined parameter chart with everything labeled and named and the equations put in there. And that would be great, but it's not necessary for this video here. But that is the equations, the f of x parameter tool and how to use it and what is it intended to be used for in order to have everything proportional and size so you can scale things up and down in a very simple, easy way. And it's very easy to use once you understand like how you're entering equations in here and making sure your parameter names here are or what is being used here as variables in the equation so that we know when we have a height, it is this number, but when we have a length, it's whatever the height number is multiplied by 2. And again, that just follows suit all the way down. That way, when you change one thing, it changes everything. And that is the goal of the parameters tool. I hope this was instructive, informative, and I hope you all have a great day.